Hello and welcome to this new video in the R Analytics course. In the previous video, we had looked at the dplyr package. We saw the following functions: select, which helps in selecting columns; arrange, which helps to sort data; filter, which gets us the desired rows based on some condition; mutate and transmute, which help us to create new columns. The difference between mutate and transmute is that when we use mutate, we get the whole table as the output with the new column. But with transmute, only the newly added column is displayed in the output. In this video, we will look at some more functions related to the dplyr package. The first function we look at now is distinct. This function helps us extract unique values. We were using the sales dataset in the previous video too. Let us open that. Now we might want to find out that how many items or dealers are there actually. We write distinct followed by the name of the table, which is sales, and then the column we want to look at, which is dealer. As we press enter, we see we get the names of the 5 dealers we had in the data set. Similarly, we can find out the items that we have. We see we have exactly 5 items that we deal in. Now, if we want to find out which dealer sells which item, then how do we go about it? We write distinct, sales, dealer, and then item. We can see the output we get for every dealer and the respective items they deal in. To present this in a better way, we can sort the data using the arrange function. We write arrange and we sort this by dealer. This is a much better way of presenting the output. You may want to find out that whether the sales in all the months was good, or was there any month in which there were no sales made. So we write distinct, sales, and then month. The output shows us all the 12 months in the dataset, which means we sold items in each and every month of the year. Next function we look at is summarize. This is an aggregate function. This function helps us generate various statistics for a variable, like sum, mean, standard deviation, etc. Say we want to find out the total of quantity. We write summarize, name of the table, which is sales, and then create a new variable, say total, and put it equal to sum of quantity. As we press enter, we get the output as 8874. Now if we want to see the total or the sum of both quantity and amount, then we will have to define two variables. So we write summarize, sales, total equal to sum of quantity, and a new variable t underscore amount as the sum total of amount. Upon pressing enter, we get the totals for both the variables in a table with their respective headers. If we also want to find out the total number of records that are there in the table, then we write summarize, sales. We then write R count, which stands for row count, and put it equal to n followed by blank brackets, which means all the rows. After defining the variable for number of rows or records, We continue to define the variables for total quantity and amount as we did earlier. As we press enter, we see we get all the three things as expected. To analyze data in more depth, we might want all these statistics for each item or would like to look at the values with respect to each dealer or sales manager. How do we get that? To get this type of data, we use a function called GroupBy. To use GroupBy function, we write that followed by the name of the table and then the name of the variable based on which we want to create groups. Say we write item over here. When we press enter, we get this output. There's a problem here. The problem we get here is that the quantity does not get summed up as per each item. By grouping, we had expected that we would get the total quantity for pen, pencil, binder, and so on. For that type of data, we will have to use two functions, summarize and GroupBy. So we start with summarize and then we write GroupBy, followed by sales and then item. For summarizing, we want the quantity variable since that is the sum we want. So we write R count equal to n and unit quantity is equal to sum of quantity, and lastly total amount is the equal of the sum of amount. Now when we press enter, we get the table with all the 5 items and their respective frequencies, total quantities and total amounts. We save this table in a variable called summary data. Thus, upon executing summary data, we get this proper table for each item and their respective statistics. We can change the group by from item to dealer to see these statistics for every dealer. We can see the output on top of the screen. To get the data for every item for every dealer, we will have to group it by both the variables, like this. Now first we get the dealer name and then the details of every dealer for each product or item. We can see that we have 4 entries for Gupta Book Depot since they deal in 4 items. We get their respective count and totals of quantity and amount too. Now that we have seen these formulae where we have used multiple functions together, that is, we have nested them, we see another example. We want the data for dealer and quantity variables for the item pen only. We also want this data set to be sorted by dealer and the report must have the top 6 rows only. Let us look at this problem one by one. To get the 3 variables dealer, item and quantity, we use the select function. We write select followed by sales and then the names of the columns. If we press enter here, then we will get the records for all the items unlike what we want. We want these 3 variables, but only for those records where the item is pen. So we use the filter function to avoid giving the whole dataset of sales. We write filter followed by sales and then the condition item is equal to pen. Basically, this is the filtered dataset out of which we want these 3 variables to be extracted. Now when we press enter, we see we get the desired output of dealer, item and quantity just for the item pen. The next task is to sort this data by dealer. For that, we use the arrange function and put the variable name as dealer, since that is the variable based on which we want to sort the data. As we press enter, we get the sorted output. Now the last thing we wanted was that the table should display just the top 6 rows. For that, we use the function called head. We just write head and press enter. The output clearly shows us the top 6 rows of the table above. This is how we solve complex problems by nesting functions with one another. What if we wanted the first 10 rows or rows 10 to 20 instead of the top 6 ones? In that case, the head function wouldn't have worked. In such a situation, we would have used a function called slice. We will see that in a while. The new function we look at now is the pipe operator. This function is a good alternative to nesting functions like we just did. This is also called chaining, since it creates a chain of functions. In this function, we write all the problem statements separately. To separate one problem from the other, we use the percentage greater than percentage symbol. Let us write the syntax for this function. We will first give the name of the dataset, which is sales. After that, we give the symbol percentage greater than percentage and then the first problem, in which we write filter item is equal to pen. Since we have mentioned the name of the dataset in the beginning, we do not have to do it again for any function. Then we separate it again and write the select statement with the 3 variables dealer, item, and quantity. We then had to sort or arrange this dataset by dealer, and lastly, we want the top 6 rows, so we write head. Basically, we gave the name of the dataset, then we filtered the data, selected the columns, arranged them based on dealer, and then finally pulled out the top 6 rows from the table. We use this syntax now in R. As we press enter, we get the exact same output from this pipe operator. Thus, in simple terms, for pipe operator, we mention the name of the dataset first and then write all the functions we want to use by separating them using the symbol percentage greater than percentage. Thus, we create a chain of functions. There is something called the in operator in R. This operator is an alternate to the OR operator. We had used the OR operator in the filter function when we had to give multiple conditions on the basis of which rows had to be selected. We wrote item is equal to pen or pencil. When we pressed enter, we got all those records where the item was either pencil or pen. Similarly, we use the in operator. We write A is equal to filter, sales, item, followed by percentage in percentage, and then combination of pen and pencil. Basically, we are writing that we want to filter the data from sales where the item belongs to the list of items in which pen and pencil are allowed. Upon executing A, we get the same table as we did with the OR operator. The last function we look at is slice. Suppose we filter the data on the basis of the item being pen only. This gives us the filtered rows based on a condition. But what if we want to filter the rows based on their position? For that, we write slice, followed by the name of the dataset, and then the range of rows. Say we want the top 10 rows, so we write 1 to 10. We can give any range like this to extract rows based on their position. These were some of the important functions in the dplyr package. This is it for this video. Thank you.